Babies, welcome to our first video lesson during this crazy time that we have. As we go through this again, we're going to be finishing up chapter 5 here. We guys just took a test on sections 1 through 4. We're skipping section 5 and going right into section 6. So section 6 and 7 are going to be related to each other on graphing what are called inequalities, and we're also going to be looking at systems of inequalities, very similar to what we did in our previous section. So as we go through this, again, linked to the video lesson, you'll see the notes for this. If you have your workbook still, that's perfect. If not, if you have the means to print off the notes for this, go ahead and do that. If not, I would grab some sort of piece of paper or something if you want to try and jot down some notes, try and get some of these things down. As we go through this, if there's any questions at all on any of the material I'm covering in these video lessons, post those questions on the comment section of the video lesson. I'll answer them because I'm sure there might be other people that might have the same questions. All right, so what we're going to look at today is we're going to talk about what's called a linear inequality. Very, 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 very similar to a linear equation, which is things we've done. A linear inequality, so take, for example, if I give you an equation like 2x plus 6. This is called a linear equation because we use the equal symbol. So a linear inequality is going to be the same identical thing, except the only difference is you're going to see our inequality symbols in here. So you're going to see less than, greater than, less than or equal to, or greater than or equal to. Just remember, as you read these inequalities, a lot of people remember that this is like the mouth. The mouth is always open towards the greater side. So here, C is going to be greater than the ax plus by. So reading it from left to right, that this side would be less than that side. Okay, and if I flip the symbol like over here, the mouth is open to this side, so now this is greater than. We always read these left to right, so you hopefully you can remember some of the inequalities and how you recognize those. Our goal for today is we're going to take these linear inequalities. Before we start doing anything with the system, we're going to just talk about how to graph them. What is it, by throwing the inequality, how is that different than an equation? What we're going to find out is that the difference between the inequality and the equation is not that great. Okay, we have, let's say, y is less than 2x or y equals 2x. Okay, both of these, inequality and equation, we can still think of it as like a line on a graph. Okay, again, they're linear because when you graph them, they form a line. The only difference, however, is that if we just had an equal sign, we would just write our line. But you're going to see here is that when we include the inequality symbol of less than, notice my line is dashed, and notice that the region of the graph below the line is shaded. Okay, so we're going to treat this line as an inequality. It's almost like a boundary. Okay, it's almost very similar to a number line where we had, okay, let's say I had 2, and I would put a open dot at 2 because of the less than, and then I would think, okay, all values less than 2 would be something over here. So we kind of did this when we talked about graphing a regular inequality. The only difference is that because a linear equality has x and y in it, you're going to see it forming a line, and we're going to think about the values of x and the values of y that are lower than or greater than whatever it might be based on that inequality. Okay, so it's very similar to what we did, but now we're going to look at it in terms of a line. I mean, that line is going to form the boundary, and what we're going to do is really shade what's being represented, very similar to what we did back with graphing normal inequalities. So first thing we're going to do is just review quickly how to graph lines. So we're not going to do anything with inequalities here. You'll notice it says y equals 2x minus 3 and y equals 1/4 x plus 4. We're just going to review how to graph these again. So again, when we graph lines, we're looking to find things in what's called slope-intercept form, y equals mx plus b, where the two values that you're going to see are m and b. So remember that m is going to represent what's called the slope of the line. The slope is, again, the rise versus the run. Rise means up or down, as run means as the line moves forward. Then you have b, which is the letter by its, or sorry, not the letter, but the number that's by itself that represents the y-intercept. And the y-intercept is the point on the graph where it crosses the y-axis. That's that middle axis on our graph. So when we graph this, for example, when I see 2x minus 3, the first thing I'm going to recognize is I have my two numbers, 2 and minus 3. So my slope, m, would be represented as 2, and my y-intercept would be negative 3. Okay, now how do I graph this? What I'm going to do is I'm going to start with that minus 3. The y-intercept tells me where to start. My slope 2, it represents my rise over run. Now, as I see again a whole number, I want to make sure that I put that whole number over 1 because I want to identify the rise and the run. Once I do that, then I'm able to plot points. So I would go up 2 over 1, up 2 over 1, and I would continue that trend, and I'm going to form a straight line. And I could do the same thing in reverse by going down 2 and left 1, and again, all of these should always form a straight line. Then what I do is just connect those dots, and I got my line. Okay, so that's just, again, practicing on graphing lines, identifying the slope and the intercept. Next one, if I see negative 1 over 4x plus 4, the plus 4 tells me that I'm going to start at 4. My slope m is negative 1 over 4, which means down 1 and right 4. So from that point, I would go down 1, left 4, down 1, left 4. I could even go up 1, left 4, and up 1, left 4 to create my line. So again, we always start from one point, and the slope is going to give us directions on where we go from there. All right, next what we're going to do is graph linear inequalities now. So now you recognize that instead of equals, I have the inequality symbol here, greater than or equal to, and here less than or equal to. All right, again, greater than or equal to because we have the mouth opening towards the left. So if I read this left to right, y is bigger than or equal to x minus 2. And here y is less than or equal to negative 3/2 x plus 6. So what we're going to do is we're going to graph these lines the same way. But now when we include the inequality symbol, again, that line, we're going to treat it as like a boundary that's going to cut the graph into 2 parts. And what we're going to do is we're going to highlight those, or one of the parts is going to represent our inequality. So again, what we got to do first is we're going to identify what is the slope and the intercept. So in this first one, I know my y-intercept is negative 2. The number in front of x is 1, so my slope would be 1 over 1. So I'm going to plot my first point, negative 2. From there, I'm going to plot every other point going up 1 over 1 by applying the slope. Okay? I'm going through that a little bit quicker, but I'm guessing we hopefully can remember from that first example how to graph the line. Once I plot all those points, then I can draw my line. And notice now here that the line serves as like a boundary. Boundary here, I have the top part of the graph above the line and the bottom part of the graph, which is below the line. So what we're going to do is we are going to shade in the region of the graph that would satisfy this inequality. So this inequality says greater than or equal to. Okay, so to represent the greater than, what we are going to do is we're going to shade the region of the graph, above that line. So by adding in the equality, we are now not just looking at the line itself, but now thinking about how the graph is split by that line and which region we want. Okay, so in this case, because it was greater than, I shaded above. Now next one we have y is less than or equal to negative 3 over 2x plus 6. So again, I know my slope is going to be the negative 3 over 2, which means down 3 and right 2. My y-intercept is going to be 6. I'll start at 6. I would go down 3, right 2. And I'm going to continue on until I can get as many points as I can. There we go. And I can even go up and left 2. And now when I graph my line, there we go. Again, that line is going to split your graph into 2 parts. So notice I have the entire bottom part of the graph here on the lower part of this line, and then I have the small corner up here above. So now my inequality says less than. So in the previous problem, I shaded above because it says greater than. So I'm going to treat this line as a boundary, and what I'm going to do now is I'm going to shade the region of the graph below this line to represent that less than inequality. Okay? So when we start throwing in the equality, we're going to graph it the same thing we did with the line, but now what we're going to look at is that region of space either above or below the line depending on the inequality. Okay, now why we are shading is because our goal in all of these is to try and find a solution to this, okay? Partly why we're graphing is a graph is a good visual on how to find a solution. So what we just talked about is, let's say that I were to give you an inequality. Sorry, this one says equals, but this one should be less than. But say I give you an inequality. This is y is less than 1x minus 3. So again, it's graphed here for us. We have, it'll ignore the dashed line for a little bit, but we shaded the region below. Now the reason why we shaded the region below is that what we want to do is we want to try and figure out what the solution is. We want to find, in this case, a value of y and x that would make this equation true. So we have, when we split this into 2 parts, the lower and top half, we have above this a whole bunch of different points. Okay, I can have a point, for example, like negative 1, 1. I can have 1, 1. I could have 2, 4. So let's say that I were to give you a point of 0, 0 versus a point of 2, negative 2. Notice that one of the points, 0, 0, falls in the unshaded region and one point falls in the shaded region. Now the reason why we're shading is that if I were to take both of these points and plug them into our inequality, so say I were to take the first one and say, okay, 0 is less than 1 times 0 minus 3. Well, what that'd give me is it'd say here, 0 is less than negative 3. Now, 0 is less than negative 3. Careful with that negative 3, but this is not true, okay? That 0 is going to be greater than negative 3. Remember that negatives are smaller than 0. So in this case, when I plug in that point of 0, 0, it does not make a true statement in the end. But if I were to plug in 2, negative 2, which falls into that region of space, so if I were to plug in the negative 2 where y goes and plug in positive 2 where x goes, what I would get is negative 2, I would get negative 2 is less than, and then this would give me 1. So negative 2 is less than 1. Well, negative 2 is less than 1, so this one ends up working out. So the reason why we are shading a specific region of the graph is because the region in which we are shading, in this case below, any point that falls within this region is going to be a solution to our inequality. It is going to be a point that makes the inequality true. Okay? Anything that falls above that region of space that we're not shading in this case, so the regions of the graph that's not being shaded in, those represent points that are not solutions. Okay, so if I were to just jot this down, anything up here would be no solution. I shouldn't say no, but not a solution. And anything below would be a solution. So that is why we are graphing. Now, the one thing that we will talk about is that what about points that fall on the line? So the line is the barrier. So you'll notice that this line is dashed. We did some lines in the previous example that are solid lines, so we'll talk about the difference there too. All right, so let's say I were to ask right now what would be a solution to these two. So a solution is going to be any point that's represented in the shaded region. So all we got to do is find a point, okay? So let's say that I picked a point, and I can pick any point, but let's say I pick right here. I'm going to pick a point of 0, 2, right on the y-axis, but notice I'm picking a point that's in the shaded region. So if I want to know that point's a solution, all I'm going to do is just plug that in. So I would say 2 is greater than x minus 2, which would be 0 minus 2. So what I'd get is that 2 is greater than negative 2, and notice that that is a true statement. So in this case, 0, 2 would be a solution. Now I picked that point 0, 2, but I could pick any point in that region of space that's going to be a solution. So if I asked you in this example to tell me what a solution to this inequality would be, again, we want to pick a point in that region of space. So heck, I'll just pick 2, 0. That would be the point of 2 to the right. Okay, and again, I could pick any point. As long as it falls into the solution, it's going to make that inequality true. All right, so here's kind of some rules as we go through this. So obviously the big difference between this is we're graphing our line, and the big thing that we just talked about is our shading. That when we shade our graph, we're going to shade above or below the line depending on the inequality symbol. So kind of to summarize it, if you were to see less than or greater than, that's the big difference. So less than, you always shade below, greater than, you shade above, and the same thing with the equal to. Now, the one thing I did not talk about yet is what do we do if we see the equal to, so the greater than or equal to or the less than or equal to. What that's going to do is that's actually going to affect the line itself, okay? So if I see equal to or not equal to, that's going to tell me whether I'm going to draw a dashed line or a solid line. So if I don't see the equal to, I'm going to draw a dashed line when I connect those dots, okay? If I see equal to, then I'm going to draw a solid line. This is very similar if you guys remember the open dot versus the closed dot when we graphed inequalities back in chapter 3, okay? So what we're going to do now is we're going to put all this stuff together. We're going to graph these linear inequalities, but we've got to think about the line we're going to draw and the shading based on the inequality. All right, so now we have negative 3/2 x plus 5. So again, if I want to graph these, we first have to identify my slope and my y-intercept. My y-intercept. So I know the slope is negative 3/2. The y-intercept is 5. So to graph this, I'm going to start my line at 5, and then the negative 3 over 2 means I go down 3, right 2. So from there I would go down 3, right 2, down 3, right 2, and I'll plot as many points as I can on my graph. Okay, and again, I can go up and left as well. Whoopsies. As many points as I can. Okay, now what I'm going to do is I'm going to graph the line. Now before I get ahead of myself, okay, I got to make sure I pause for a second. Here, notice the inequality symbol says less than. So based on what we just talked about, if it says less than, that means we are going to draw a dashed line. So essentially a dashed line is saying all those points that I just plotted, those points are not a part of my solution. So the dashed line is just showing I don't want to include those points. And then because it also says less than, we are going to shade the region of the graph below the line. Basically, the region is showing, or what I'm shading in is showing that any point that falls in that region of space would be a solution to this inequality, okay? And I can pick a point if I wanted to. For example, I could pick the point, let's say 0, 0. Since 0, 0 lies in that space, if I were to plug 0, 0 into that inequality, I should get a true statement, okay? All right, now our last example here, just in case you see this, all right? We always want to graph lines, and it's so easy to graph a line if it's written in slope-intercept form. But what if we see a line written like this? Okay, think about our systems of equations. This would be a good case we'd want to use elimination, but since we have a single equation, how do I graph this? So just to remind you guys, this is what's called standard form, and I taught you guys a while ago what's called the cover-up method on how to graph this. Cover-up method says that if I want to graph these, I can find the x and y intercepts, okay? So let me show you how. So to cover up, what I'm going to do is I'm going to add in here a little box. So let's say that I wanted to find my y-intercept. What I'm going to do is I'm going to take my little box, I'm going to cover up x. And what I have is an equation that says negative 3y is less than or equal to negative 15. Okay? Now that's a little equation I can solve. If I divide both sides by negative 3, I know that these will cancel. On the right side, I'd get 5, and I'd get y is, now one thing we also got to remember as I go through this is that I divided by a negative. So if you remember, we're going to take our inequality and flip that. So I have y is greater than or equal to 5. Okay, so I'm going to put that point right there. 5 would be that y-intercept. Then I would take that box and now move it over, and I get another inequality that says 5x is less than or equal to negative 15. So now if I divide both sides by 5, I would get x is less than or equal to negative 3. Here I would not need to flip the line, or flip the inequality sign, I'm sorry, because I'm not dividing by a negative. So x is less than or equal to negative 3 means I'll put a point at negative 3. Okay, now I'm going to graph my line. Now, because it says less than or equal to, I know that I can draw a solid line, okay? Solid line because of the equal to. Now, the way I graph this is a little bit different than what I did before, okay? So follow me on this one. Our two answers here are going to tell us how to graph this. So I have y is greater than or equal to 5, and x is less than or equal to negative 3. So here's 5 on my y-axis. Greater than would be anything above it. If I went here, x is less than or equal to negative 3, less than means I'm going to go left. So notice up and left means I'm going to shade the region of the graph that's above this line. All right, so by graphing it this different way, by finding the intercepts, okay, I got to think a little bit on where I need to graph it. So even though it says less than or equal to, I ended up actually shading it above the line, and that is because some of the negatives and some of the things that happened, okay? But again, here I had a solid line because of the equal to, and I shaded based on the inequalities I'm given. All right, so once we see things in slope-intercept form, pretty easy to understand of what the graph looks like. Standard form is going to be a little bit different to do in the end. But again, we're looking at what is the inequality symbol, tells us about our line being dashed or solid, and whether we shade above or below. If you guys have any questions, jot those down, throw those comments onto the video lesson itself. Otherwise, good luck with the practice problems, and we'll see you guys next section.